Have you ever wondered what happens to your body in space? The cosmos, a vast expanse of unknowns, has captured our imaginations since time immemorial. It's a place of infinite wonder where stars are born and galaxies endlessly unfold. Yet this enchanting frontier is not as hospitable as it is mesmerizing. Our bodies, so intricately designed for life on Earth, face a myriad of challenges when we venture beyond our planet's atmosphere. The zero-gravity environment, the isolation, the cosmic radiations, all leave an indelible mark on our physiology in ways that are both fascinating and a little unsettling. In this cosmic voyage, we will delve into the top 10 surprising impacts of space travel on the human body, from muscle atrophy and bone density loss to fluid redistribution and psychological hurdles. We will uncover the stark reality of what it means to be a human in space. Are you ready to embark on this cosmic journey? Prepare to have your mind blown. Starting our countdown at number 10, we have changes in height. Yes, you heard it right. Space travel can literally make you taller. Now, this isn't because of any magical elixir or secret space diet. It's all about gravity, or rather the lack of it. In the absence of Earth's gravitational pull, the spine experiences a phenomenon called spinal elongation. This is where the vertebrae, which are usually compressed together under gravity, have the chance to spread out a bit. As a result, astronauts can grow up to 2 inches taller while in space. It's a temporary change, though. Once they return to Earth, gravity takes over again, compressing the spine back to its original length. But for a brief while, they get to enjoy a slightly loftier perspective. So if you've ever wished to be taller, space might be your answer. But remember, what goes up must come down, especially when gravity is involved. At number 9, we discover a less desirable impact: vision impairment. The absence of gravity in space leads to a phenomenon known as fluid redistribution. This is when body fluids, including blood, shift upwards, causing an increased pressure in the head and eyes. Now, why does this happen? Well, on Earth, gravity naturally pulls fluids down towards our feet, but in space, there's no gravity to do this job, so the fluids float upwards, causing a traffic jam of sorts in the upper body. This fluid shift can lead to swelling in the optic nerve and changes in the shape of the eye, which can cause blurry vision and other vision problems. Some astronauts have even reported needing glasses upon returning to Earth after extended periods in space. So while the view from space might be breathtaking, the effects on our eyesight are a stark reminder that we humans are indeed creatures of Earth. Perhaps space isn't the best place for a perfect 20/20th vision. Number 8 brings us to a common ailment among astronauts: space adaptation sickness. You might be familiar with the feeling of seasickness, motion sickness in a car, or even air sickness during a turbulent flight. Now imagine those feelings amplified and in zero gravity. This is what space travelers often experience in the first few days of their journey. Symptoms of space adaptation sickness include nausea, dizziness, and headaches, much like its terrestrial counterparts. So what's causing these discomforts? It's all down to our bodies adjusting to the changes in gravity. Our brain and inner ear, which control our balance and spatial orientation, get thrown for a loop when gravity is taken out of the equation. One could say that being an astronaut is not just about having the right stuff mentally and physically, but also having the right stomach. After all, hurling through space is enough to make anyone queasy. Space travel isn't for the faint-hearted or the weak-stomached. Coming in at number 7, we have muscle atrophy. Imagine a world where even the act of standing doesn't engage your muscles. This is the reality in space, where the zero-gravity environment makes simple tasks like walking or lifting objects effortless. But like the saying goes, use it or lose it. Muscles that don't experience regular strain start to weaken and shrink, a condition known as muscle atrophy. For astronauts, this presents a major problem. To counteract the effects of muscle atrophy, they follow rigorous exercise regimes. Picture treadmills and resistance devices specially designed for zero gravity, becoming a crucial part of daily life in space. Astronauts dedicate around 2 hours each day to high-intensity workouts, maintaining muscle strength and cardiovascular health. While these routines are effective, they aren't perfect. Some muscle loss is inevitable, making recovery back on Earth a challenge. But it's a small price to pay for the opportunity to explore the cosmos. In space, even moving a finger becomes a workout. Halfway through our countdown at number 6, we find bone density loss. In the vast expanse of space, the lack of gravity plays a rather unexpected role. It leads to a decrease in bone density in astronauts, somewhat mirroring the condition of osteoporosis here on Earth. Picture this: in a gravity-rich environment like ours, our bones are constantly working against the pull. This continuous effort keeps them strong and dense. However, in the weightless environment of space, this natural workout is absent. The bones don't have to work as hard, and as a result, they begin to lose density. It's like an unused muscle that gradually weakens over time. Now, this isn't a one-off event. The longer astronauts spend in space, the more significant the bone density loss. And while exercise routines and nutritional supplements help, they don't entirely prevent this loss. So, ironically, astronauts have to work their bones off to stay fit in space. At number 5, we have changes to the immune system. Now, space travel isn't just a thrilling voyage through the cosmos, it's also a stress test for our bodies, especially our immune system. Imagine living in a sterile environment like the International Space Station, where the usual bacteria and viruses we encounter on Earth are absent. Sounds great, right? Not quite. This sterile environment can actually weaken your immune system. Our bodies are built to regularly fight off tiny invaders, and when they're not doing that, they can get a bit rusty. Plus, the physical and mental stress of living in space can further weaken your immune response. This could increase the risk of infections, both from the few microbes that do make it into space and those that you'll encounter when you return to Earth. So, while space travel might sound like a dream come true, it's also a battle for your immune system. Space travel isn't just physically challenging, it's a battle for your immune system too. Number 4 brings us to altered sleep patterns. Now imagine trying to sleep when you're circling the globe every 90 minutes. That's 16 sunrises and sunsets in a single 24-hour period. Confusing, right? This rapid cycling of light and dark is just one of the many factors that can upset an astronaut's circadian rhythm, leading to disrupted sleep patterns. Add to this the stressful environment of space, the constant hum of machinery, and the cramped living conditions, and it's no wonder astronauts often report difficulty getting a restful night's sleep. In fact, research has shown that many astronauts rely on sleep medication during their missions. But it's not all bad news. NASA and other space agencies are constantly researching and developing new ways to help astronauts get the sleep they need. From carefully timed light exposure to high-tech sleeping quarters, these strategies are designed to mimic the natural sleep-wake cycle as closely as possible. In space, the concept of a good night's sleep takes on a whole new meaning. Cracking the top 3, we have psychological challenges. The human mind, much like the body, can react in unpredictable ways to the unfamiliar conditions of space travel. Isolation, confinement, and the relentless stress of being in an alien environment can lead to a cocktail of psychological responses. Imagine being confined in a small space with the same faces, the same routines, and the same views day in, day out. It's a recipe for monotony, and the human mind doesn't cope well with that. Feelings of isolation can creep in, even though you're surrounded by your crewmates. Then there's the stress factor. The constant awareness that you're thousands of miles away from home, in a hostile environment where even a small mistake can have catastrophic consequences. This can lead to anxiety, stress disorders, and even depression. So, as we can see, space travel is as much a mental challenge as it is a physical one. At number 2, we find cardiovascular changes. Now imagine a roller coaster ride, thrilling but often heart-stopping. That's what your heart experiences in zero gravity. The lack of gravitational pull means our heart doesn't need to pump as hard as it does on Earth. This might sound like a vacation for our ticker, but it's not all smooth sailing. Zero gravity can cause irregular heart rhythms, a condition known as cardiac arrhythmia. It's like the heart is losing its beat, skipping a note here and there. This can be harmless, or it could lead to more serious health problems. Astronauts have been known to experience these rhythm changes during their space sojourns, Space travel also affects blood flow and can cause a decrease in blood pressure. It's a whole new world for our cardiovascular system up there, where the rules of earthly physics don't apply. So, while space travel might be a journey of a lifetime, it sure gives the heart a workout. The heart truly goes on a roller coaster ride in space. And finally, at number 1, we have cosmic radiation. This invisible threat is one of the most significant challenges faced by astronauts in space. Cosmic radiation is composed of high-energy particles that originate from the Sun and other celestial bodies. This radiation can penetrate spacecraft and even the human body, causing damage to cells and DNA. The long-term exposure to cosmic radiation significantly increases the risk of developing cancer. The danger is not just about the exposure during the space mission, but also the potential long-term effects after returning to Earth. It's a silent, unseen hazard that astronauts must grapple with every time they venture beyond our planet's protective atmosphere. Moreover, the current shielding technologies are inadequate to fully protect astronauts from this space hazard. Thus, finding effective ways to shield astronauts from cosmic radiation is a top priority for space agencies around the world. The cosmos might be beautiful, but it's also deadly. So there we have it, the top 10 surprising impacts of space travel on the human body. From the heights of space, our bodies undergo fascinating and sometimes alarming transformations. We've learned that astronauts can grow taller, their vision may become impaired, and they could experience space adaptation sickness. Our muscles don't escape the effects of zero gravity either, with muscle atrophy being a common issue, along with significant bone density loss. Even our immune systems don't remain untouched, undergoing changes that we're still striving to fully understand. Space travel can also disrupt our sleep patterns and present unique psychological challenges. Our hearts are not exempt from this cosmic journey either, as cardiovascular changes have been noted, and let's not forget the invisible danger of cosmic radiation. Space travel pushes the human body to its limits, but it's all part of our quest to explore the final frontier. And now we've reached the end of our cosmic journey, but the exploration doesn't have to stop here. If you learned something new today, hit that like button. It's a small step for you, but a giant leap for our channel. We'd love to hear your thoughts too. What was the most surprising effect of space travel on the human body for you? Let us know in the comments section below. Space is vast, and there's so much more to learn. So if you're ready for more interstellar adventures, subscribe to our channel and press the bell icon. This way, you won't miss any future journeys into the unknown. Finally, if you think this video would be interesting or useful to someone you know, don't hesitate to share it. After all, space exploration is a collective endeavor. Let's discover the mysteries of the universe together. Remember, the stars are the limit. Stay curious, stay informed, and as always, thanks for watching.